56. All of the following are condensation polymers except something you just have to memorize. The starch, nylon, and proteins all lose water, meaning the one side of the chain has H, and another side has the hydroxide functional group. And by losing water, by forming water and losing it, you get to connect the chain. So that happens to nylon, protein, and starch. So the answer is polyethylene. Okay? Polyethylene is just a combination of a bunch of these guys. Alright, so 57, methanol can be gently oxidized with hot copper metal. What is or are products of this oxidation? Okay, notice it's oxidized, and if you can draw the methanol structure, and they look like, okay, so to oxidize we have to lose that hydrogen. So this is what you get. This is formaldehyde, but in a more systematic way to speak is methanol. It's aldehyde group. So the answer is D. Which statement does not describe the benzene? Okay, benzene is aromatic because it's a cyclic, and also has this shape. It's not perfect drawing, but it's like a hexagon with double bond inside. Okay, we have a resonance because electrons can move. Well, technically they don't really move, but we can kind of imagine it that way. It's more like this shape. Okay. You have partial bond that's shared equally, and well, I don't know why I circled this. Okay. This is correct. It's aromatic, so you have to cross it out, and it exists in two isomeric form. Okay, by the way, I need to emphasize that it does not. So this is true, and this is false. Let me explain why. Isomers, the arrangement of atoms in the compound must change, but we don't change the compound, meaning that we have carbon here, carbon there, and that we're not moving it around. It's just we are moving the electrons around, so it's not isomers. Rather, you should say this is resonance. So the answer is B. Yes, they do undergo a substitution reaction, especially with halogen. And D, it can react to form three different products with this formula. Yes, this is what we call, you're going to learn this in organic chemistry, the meta or ortho meta para. Yeah. So try that. I'll make this simple. Okay, you can have this ortho and meta and para. Okay, they're not same thing. It's more like structural isomers when we have that. So you can form three different kinds of it. So this is true, so it's not the answer. Alright, 59. Almost done. All of the following atoms comprise part of a peptide functional group. Okay. Peptide functional group except I didn't, okay, this is not part of the question. I just brought it because I don't want to draw too much. It can get very messy. So this is how the peptide bond looks like. You see the main chain here. the bond between the nitrogen and the carbon, that will be the peptide bond. It's to make the polymer and to create the long chain of protein. And as you see there, you see hydrogen, nitrogen, oxygen. So we have hydrogen, nitrogen, oxygen, but the question said except we don't have phosphorus. You see phosphorus in DNA, you will see that in the phosphodiester linkage, the third carbon of one nucleotide with the fifth carbon. So this is more relevant to the DNA structure, not the protein structure. 60. Which vitamin is most soluble in water? Okay, again, these pictures are not from the question, but I brought them because drawing them would take too long and make the video too long as well. So let me, if you memorize or if you at least know some chemistry trivia, the fat insoluble or fat soluble, not the water soluble, vitamins are A, D, K, and I believe E. Okay. And the water soluble is obviously C. Now if you are familiar with the structures, we can take a look. So this is vitamin A. Okay, and you will see why it's fat soluble. You see a bunch of hydrocarbons in a big chain until we hit the hydroxide functional group on the very right side. Even though hydroxide makes the compound soluble, but we have a big chain of nonpolar region, so this is more relevant to fat soluble. So this is vitamin A. Again, the vitamin K, even though we have two oxygen, the carbonyl group here, we see a big nonpolar on the right side. So this is vitamin K, which is fat soluble, not water soluble. So anytime you hear fat soluble, it's opposite to water soluble. And let's take a look at vitamin C. Look how many hydroxide we have. 1, 2, 3, 4. And it's much smaller size than the vitamin A and vitamin K in terms of the size of the molecule. And so this has to be very water soluble. So OH is a water, it will not be very miscible with water, so water soluble. And finally, vitamin D, as you see, just like the vitamin A and K, you see a big chain of nonpolar, except the very ending OH here. So this is, I believe this is vitamin D2. So vitamin D has like 5 different shapes, and this is one of them. And this is fat soluble as well. Okay, so all A, K, D are all fat soluble. C is the water soluble.